Welcome to this video tutorial on measures of variability, also known as measures of dispersion. In this segment, we will discuss measures that tell us how spread out or dispersed data values are. These measures include the range, the interquartile range, the variance, the standard deviation, and the coefficient of variation. While each of these measures is calculated differently, they all tell us the same thing, that is, how the data are spread out or dispersed. To illustrate what is meant by dispersion, let's take a look at grades from two groups of students, one taking a class during the day and one taking a class at night. I made these numbers simple to illustrate a point, and I only used 5 to make the calculations easy. Take a look at these two sets of numbers and think about what you see. At first glance, you should be able to see that the mean for both is the same, a grade of 80. We can see that just by looking at the numbers. The balancing point is in the middle, and that's at 80. But if we calculate it formally, we get x bar 1, the sample mean for sample 1, the day students, and it is 76 plus 78 plus 80 plus 82 plus 84 divided by 5, or 400 divided by 5 is 80 for the day students. And x bar 2, the sample mean for sample 2, the night students, is 60 plus 70 plus 80 plus 90 plus 100 divided by 5 is also 400 divided by 5, or 80. So we see that the mean is the same for the day class and the night class, even though the grades are different. Now let's take a look at how these numbers are distributed. Here is a graph showing how the 5 grades for the day class are distributed. You can see that the mean is 80 and all the other grades are clustered in and around the mean very tightly. A graph of the night class shows us a very different story. Yes, the mean is still 80, but you can see that the grades are dispersed from one end of the graph to the other. The lowest grade is a 60 and the highest grade is 100, so the spread is very large for the night class and much smaller for the day class. That brings us to the realization that the mean is not the only number that describes a data set. We need other measures to get a clearer picture of the data, and those measures are called measures of dispersion or measures of variability. The simplest of these measures is the range. Here we simply take the largest value minus the smallest value, and it gives us the spread or range of the data. The formula for the range is written as follows. The range is equal to the largest value minus the smallest value. For our example with the 5 students from the day class, you can see that the highest grade is an 84, the lowest grade is a 76. So to calculate the range, we take 84 minus 76 and we get 8. So the range for the day class is 8. Now let's look at the night class. You can see that the night class has 100 as its largest value and 60 as its lowest value. So the range for the night class is calculated as 100 minus 60, which is equal to 40. So the range for the night class is 40, and the range for the day class is 8. The next measure of variability we will discuss is the interquartile range. To calculate the interquartile range, we take Q3, quartile 3, minus Q1, quartile 1. An example of this is shown in the previous tutorial on percentiles and quartiles. We had calculated the quartiles for 15 student grades as follows. Q1 was 69, Q2, also known as the median, was 77, and Q3 is 84. Again, if you need a refresher on how this was done, please review the video tutorial on percentiles and quartiles. So now you are ready to calculate the interquartile range, which measures the middle 50 or middle spread of the data. Q3 minus Q1 is 84 minus 69, which is equal to 15. So the interquartile range for this data set is 15. While the range and the interquartile range only use 2 numbers to measure variability, the variance is a measure that uses every single number in a data set. So instead of just taking the highest number or the highest quartile and the lowest number or the lowest quartile, this measurement utilizes all the numbers. The way it is calculated is to take each and every number and measure the difference between those numbers and the mean. That is why it is sometimes called the deviation about the mean. The symbol for the population variance is sigma squared, and it is written like this, with the lowercase Greek letter sigma squared. The formula for calculating the population variance is as follows. Sigma squared is equal to the sum of the x sub i's minus mu squared divided by n, and that's big N because it's a population, so population size. Let's look at this formula very closely. This means we sum up what is in parentheses, and that is each and every x sub I, or in other words, each and every data value from mu, the population mean. After all these values are subtracted from the mean and squared, they are summed and then divided by big N, the population size. In most cases of statistical analysis, we get our data from samples, not from the population. When we calculate the variance from a sample, it is called a sample variance, and the formula changes slightly. First of all, we use s squared instead of sigma squared to denote the sample variance. Remember, we use sigma squared for the population variance. The formula remains the same, except that the sum of the squared deviations around the mean is divided by n minus 1, not n. Also, instead of mu, we have x bar. The reason we divide by n minus 1 instead of n is to account for the data coming from a sample rather than a population. Again, since this is a sample, we take each x sub I and subtract from the sample mean x bar, not the population mean mu. So you can see the notation in the numerator is x bar and not mu. Let's take a look at these two formulas one more time side by side. On the left side, you can see the formula for the population variance, and we use the Greek lowercase letter sigma squared to denote the population variance. On the right, you can see the formula for the sample variance, and we use s squared to refer to that sample variance. In statistics, since we are usually dealing with sample data, we mostly use this formula on the right. The other differences are in the use of x bar for the sample instead of mu, which is the use for the population mean, and of course big N always refers to population size and little n refers to the sample size. The denominator for the population variance is big N. The denominator for the sample variance is little n minus 1. Let's take a look at how we would calculate the sample variance. Let's use our sample of 5 student grades to see how we would calculate the sample variance. So here we have 5 student grades for the day class. Let's start with the day class, and we have all the x sub i's listed here: 76, 78, 80, 82, 84. Okay, so the next thing we need to do is to make a column for the mean grades. So the mean grade is an 80. If you remember, we calculated 80. So mean grade is x bar, and that is 80. Okay, now just to refresh your memory, if you'll recall, x bar is equal to sum of the x's divided by n. And if you add up 76 plus 78 plus 80 plus 82 plus 84 divided by number of students we have, which is 5, you would get 400 divided by 5, and that's 80. So that's how we got this mean grade of 80. So now we have a column with x bar and 80 all the way down. In the next column, we will put the deviations about the mean. So let's write that down: deviations about or around about the mean. And what that means is we're going to take each number from column 1, which are the x sub i's, and subtract it from each number in column 2, which are the x bars. So we take each number from column 1, 76 minus 80, and we get minus 4. 78 minus 80, we get minus 2. 80 minus 80, we get 0. 82 minus 80, we get 2. And 84 minus 80, we get 4. And if you add that all up, you will always get 0. And I say always, so let me write that down. The sum of the x sub i's minus x bar will always be equal to 0. And if you think about that for a minute, you'll understand why that is so. That is true because you have the deviations about the mean. So you have deviations below the mean, -2 and -4, and you have deviations above the mean, 2 and 4, and they will cancel each other out. The negatives below the mean will cancel out the positives above the mean. So we need another column to calculate the variance, and that column we're going to call the squared deviations about the mean. And that is simply taking the third column, x sub I minus x bar, and squaring it. Okay, so the first number, -4 squared, would be 16. -2 squared would be 4. This is 0. This is 4. And this is 16. And now, if we add that up, we get the sum of the x sub i's minus x bar squared. And if we add up all of those numbers, 16 plus 16 is 32, plus 4 and 4 is 8, 32 plus 8 is 40. So we get 40. Okay, and now we're ready to calculate the sample variance. And remember, the formula for the sample variance is the sum of the x sub i's minus x bar squared divided by n minus 1. And so we take the sum of the x sub i's minus x bar squared. We did that in the fourth column here. We calculated 40. And then we have n minus 1, and n is 5. That is, the sample size is 5 minus 1. So we get 40 divided by 4, and that's an easy number. So we get 10. Now let's look at how we would calculate the sample variance for the night class. We do the calculations the same way. We make a column for all the x sub i's. Now, if you remember, the numbers for the night class were 60, 70, 80, 90, and 100. We also had 5 grades there. And the mean grade was the same as the day class. And if you take all the x sub i's and divide it by n to get x bar, you take 60 plus 70 plus 80 plus 90 plus 100 divided by little n. Little n is the sample size, 5. And so we get 400 divided by 5, which is 80. So we get the same x bar for the night class as we did for the day class. And that's why it's important to calculate the variance, because we can see that the variation, even if we don't know much about statistics, anyone can see that the variation from a grade of 60 to a grade of 100 is a bigger dispersion, bigger variation than the day class. Let me scroll up to the day class. And you can see the grades for the day class were between 76 and 84. So even though the mean is the same for the night class and the day class, you're going to see that the variance is very different, and that's what we're going to do. Okay, let's get back to the formula. It was x sub I minus x bar squared. So the next column we're going to make, the third column, is for the deviations about the mean. And so that would be x sub i's, the numbers in the first column, all of the grades, minus x bar, the sample mean. So you have 60 minus 80 would be minus 20. 70 minus 80 would be minus 10. 80 minus 80 is 0. 90 minus 80 is 10. And 100 minus 80 is 20. And what do you suppose if we were to sum up all of these x sub i's minus the mean, what would we get if we added all these numbers up? And you can see that all of the numbers below the mean are balanced out by all of the numbers above the mean. So all of the numbers that are deviating about the mean cancel each other out, and as I said before, you will always get 0. Therefore, we need the squared deviations, and so the squared deviations would be column 1 minus column 2 gives you column 3, and then you take column 3 and square it to get column 4. So negative 20 squared would be 400. And you see what happens when you take a negative times a negative, you get a positive. So we get rid of that negative sign. Negative 10 minus negative 10 gives us 100. 0 times 0 is 0. 10 squared and 20 squared. And now if we add up all of these numbers, we get the sum of the x sub i's minus x bar squared. Add 400 plus 400 is 800, plus 100 and 100 is 1,000. So we get 1,000. And now we're ready to calculate the sample variance. The sample variance, remember, is denoted by S. If it is the population variance, we use lowercase sigma, the Greek letter sigma. But this is for a sample of 5. So the formula is the sum of the x sub i's minus x bar squared divided by n minus 1. And that is equal to 1,000 divided by n is 5 minus 1. So we get 1,000 divided by 4, and that would be 250. So the variance for the night class is 250, and the variance for the day class was 10. Let me see if I can get that on the same screen. Okay. So you can see the variance for the day class is just 10, and you can see the variance for the night class is 250. So there's a big difference in the variation between the day class and the night class. We use these numbers, variance, to compare one group with another group in terms of variability. In this case, both the day students and the night students had an average grade of 80. But which class had more variability in the grades? We can see here the measures of the variance for the night students is 250, and that's much, much greater than the variance for the day students, which was only 10. So as a way to compare the two groups, the larger variance shows more variability. So we can conclude that the night students had more variability than the day students in the distribution of their grades. Another measure of variation that we use in statistics is the standard deviation. The standard deviation is defined as the positive square root of the variance. For the population standard deviation, we use the symbol sigma, and it is simply the square root of the population variance, sigma squared. For the sample standard deviation, we use the symbol S, and it is calculated as the square root of the sample variance, S squared. So for our day students, the sample variance was calculated as 10, and the standard deviation would be 3.16. For the night students, the sample variance was calculated as 250, so the standard deviation would be 15.81. What is the point of converting the variance to a standard deviation? All it is a square root. Well, that's exactly the point. Remember, the variance gave us squared differences, so the units are considered squared units. To get the units back to the same measurement as the original data, we need to take the square root of the variance. So for example, if the original data was pricing data instead of grades, then the data units are in dollars, and the variance is then represented by squared dollar units. To get the units back to just dollars, not squared dollars, we need to take the square root of the variance, and that is what the standard deviation represents. It gives us a measurement that is in the same units as the original data. We will talk more about the standard deviation since it is a measurement that is used a lot in statistics. Now let's see how we would use Excel to compute the sample variance and the sample standard deviation. Here are the functions we would use. For the variance, we would type equal for function and then var.s and then the range. And for the standard deviation, it's equal stdev.s and the range. Let's see how this is done in Excel. Let's use Excel to calculate the variance and the standard deviation for the day and night students. First, I'm typing in labels. I have the day students in column 1, the night students in column B, and I'm going to type in the variance and the standard deviation for the day students and the variance and the standard deviation for the night students, just as labels. Okay, now I'm typing in all the numbers. We have 76, 78, 80, 82, and 84 as the original data numbers for the grades of the day students. We have 60, 70, 80, 90, and 100 for the grades for the night students. Okay, I'm going to choose H as the column for the output. Now I'm typing in the function box the formula for variance equal var.s and then the range of the cells I want. I want the range for the day students first, so let's do A2 through A6. Hit enter and you get 10, and that's exactly what we got when we calculated this by hand. Let's do the variance for the night students. Equal var.s. The range is B2 through B6. And we get 250, which is the same number we got calculating by hand. You see how much simpler it is to use Excel for the calculations than doing it by hand. Even though we only have 5 numbers. All right, the standard deviation is the square root of the variance. That's an easy number to calculate, but we can have Excel do it. We type in equal stdev.s and then the range for the night students, and that's B2 through B6, and you can see 15.81 is the standard deviation. So this is really a very simple calculation using Excel. It's only 5 numbers and it took us a little bit of time doing it by hand. Imagine if it was 50 numbers. All right, and that's it. That's all there is to using Excel. Let's go back to our discussion of measures of variation. In some cases, we may be interested in determining how large the standard deviation is relative to the mean. The coefficient of variation gives us this measurement and is usually expressed as a percentage. The formula is as follows. CV, the coefficient of variation, is equal to the standard deviation divided by the mean times 100%. So for the day students, we take the standard deviation, or 3.16, divided by the mean, 80, times 100%, and we get 3.95. That is 3.95%. For the night students, we take the standard deviation of 15.81 divided by the mean, which was 80, times 100%, and we get 19.76%. This tells us for the day students that the sample standard deviation is only 3.95% of the mean, whereas the sample standard deviation for the night students is 19.76% of the mean. This is a relative measure, meaning that it is very useful for comparing variability of data that have different standard deviations and different means. Let's see how we can use Excel to get most of the descriptive statistics we have covered in this tutorial. Here are the steps. You can pause this video to copy them down. So let's see how it's done using Excel. Okay, here we have our data set of student grades that we were using for this tutorial. We have 5 student grades for the day class and 5 student grades for the night class. Now the first step is to go to the Data tab and click on Data Analysis. Well, when we go to the Data tab here, there is no Data Analysis group, which is an add-in for Excel. It should be all the way here on the right-hand side of this ribbon, right here. That means you have to add it on yourself if you intend on using it. To do this, let's go to the File menu and click on Options at the bottom and then click on Add-ins. So let's see how we would do that. Okay, we click on Options here at the bottom. We click on Add-ins. You see that? All right, now you can see up here it says Active Application Add-ins, and there are no Active Application Add-ins. So we highlighted Analysis Toolpack. We have that there. Go at the bottom where it says Manage Excel Add-ins. Click on Go. And now you'll see the add-ins that are available, and I will check Analysis Toolpack and say OK. Okay, now when you click on the Data tab, so click on the Data tab, and you go all the way to the right-hand side over here, you can see that we now have a group called Data Analysis. Click on Data Analysis, and now click on Descriptive Statistics, and click OK. Okay, up comes a dialog box for the input range. We're going to input the range for the day students and the night students. So that would be column A, row 2 to column B, row 6. And then the output range is simply where I want it to be output. I could output it to a new worksheet. I want it outputted to column E1, starting at E1. And now check Summary Statistics and click OK. And that is it. We have column 1 with the day students. I can change the labels there. We have column 2 with the evening students or the night students. And I'm just fixing the columns there so it's a little spread out a little bit better. Okay, I decided to go into the columns and format the cells so that column F and column H are centered. So now it's a little clearer, easier to see. You can see the output table of the descriptive statistics for the day students and the night students. We have the mean, we have the standard deviation, we have the range, we have many other numbers we haven't learned yet, but you can see this is a very useful tool for getting all the descriptive measurements without using the functions one at a time. And here we get them in one nice neat table. Remember again, check the Data tab, look all the way on the right-hand side and see if you have a data analysis group. If you don't have a data analysis group, you have to go back, as I showed you in this video, to the File menu under Options, Add-ins, and manage the add-ins and add in that analysis tool pack. That's it for this tutorial on measures of variation and dispersion. We covered the range, the interquartile range, the variance, the standard deviation, and the coefficient of variation. I hope you enjoyed this tutorial, and I hope you learned something.